Thank you all for coming. This is possibly the worst time slot you can have at a conference, like 9 a.m. on the last day, so I'm really happy that so many of you turned up. This is actually my second year speaking at SREcon Asia, so I'm really glad that I managed to get invited again. Last year, for those of you who were here, I was talking about reliable launches at scale. This year, I'm going to talk about interviewing, and I'm going to talk about interviewing for systems design skills. Now, you might be asking, what does this person know about interviewing? Why is he talking to us? So I've been working for Google for more than 10 years at this point. I have conducted more than 200 interviews in that time. I've also been a member of Google's hiring committees, so this is where we make recommendations for individual candidates to be hired by Google or not. I do internal training workshops for Google's interviewers. So these are the workshops where we prepare Google engineers for interviewing external candidates. I've also run workshops for external candidates where we prepare candidates for interviewing with Google. And for a couple of years, I used to run a weekly internal event in the Zurich office that we call Interview Club, where Google's interviewers come together and practice interviewing with each other. So you might conclude that, yeah, maybe that person knows a little bit about interviewing, and you might even be right if you conclude that. But interviewing SREs, it turns out, is really, really hard. Right? And we're gonna get to a little bit. We're gonna get to why it is that hard in the rest of this talk, because well, this is the point where my slides would be really useful. I'm just going to do this without the slides, so you're just going to have to. You're going to have to listen to me. About 10 or 15 years ago, when Google was building its first site reliability engineering teams, we had a problem, which is that the job description of site reliability engineering did not exist at the time. So we were thinking, well, who are we going to hire for these teams? We can't hire site reliability engineers because they don't exist. And when this question was asked to Ben Traynor, who is Google's Senior Vice President for SRE, when Ben Traynor was asked, well, who should we hire for this new team? He drew up a almost famous curve now that would be on the slides if we had slides. He basically said, well, site reliability engineering is really hiring on a spectrum. We're going to hire from software engineers, and we're going to hire from the pool of systems engineers, and we're going to hire from everywhere in between. So we're going to hire these hybrid candidates as well that... So I've just been told that I might have to do without the slides for a bit. So we were going to hire from this pool of software engineers, systems engineers, and everybody in between. So people that had partial software engineering experience, partial systems engineering experience. They were sort of hybrid candidates. So you might be thinking, well, okay, I know how to hire software engineers. You invite people in, you maybe give them a coding problem, you give them an algorithm problem, you have them write some code on a whiteboard, and then you figure out whether they're good software engineers or not. You might also think that you know how to hire good systems administrators. You give them some Linux questions, some Unix questions. You ask them how they would perform standard system administration tasks, and then you know whether to hire them or not. But then with SRE, you get this third dimension into the picture, which is systems engineering. Then we need to figure out, how do we hire good systems engineers? Now, if we want to figure out how to hire systems engineers, it can be very useful to go back to the definition of what systems engineering actually is, because that will give us an idea of what types of skills we should hire for when we want to hire systems engineers. And most of the time, when I want to look up a definition of something, I'm lazy. I go to Wikipedia, because that's where everybody knows when they want to know about the basics of something. And I pulled the definition off of Wikipedia. And the definition off of Wikipedia is that systems engineering is an interdisciplinary field of engineering and engineering management that focuses on how to design and manage complex systems over their life cycles. So that gives us 4 skill categories to hire and to probe for in an interview and to interview for. So we get the skill categories of design, management, it's about complex systems, and it's about management over the life cycle. So we can very easily break these down into different categories that we want to interview for. So if we're interviewing for design skills, then we want the candidates to design a system for us in the interview that solves a particular problem. In that design, we want them to be aware of performance needs, resource needs, bottlenecks in the systems. We want a systems engineer to be able to design systems from scratch, not just by putting together existing components, but we want them to be able to design systems for problems that have not been solved yet. So a good systems engineer needs to be able to solve a problem from scratch. If they want to use pre-built components, they need to know how these components work and why they're a particularly good fit for the problem that we're solving. And in the design, we also want a good systems engineer to be aware of service level needs and of failure modes for a system. So that covers the design part. The next part, we had design and we had management. So for the systems management part, we want a systems engineer to design a system for manageability. So build componentized systems, build systems that preserve separation of concerns between the individual elements of the system. Avoid single points of failure, avoid scalability bottlenecks. That's all part of manageability for a system. Now, in the interviewing context, the next part was that systems engineering is about complex systems. And real-life systems, real-world systems, they are usually very complex, the types of systems that site reliability engineers work on. Now, this poses a bit of a problem for an interview situations, because interview situations are time-limited. We typically don't have unbounded amounts of time for the interview. So we don't want to get into too much complexity as we're doing the interview situation. But in the context of large systems design, there is something that works in our favor when we want to interview for complexity, which is that even very simple problems become complex when you scale them up. You can start with a very simple problem, and we're going to see one in not in a couple of slides, in a couple of minutes when I start talking about it. And even very simple systems become very complex as you scale them up. So if you're interviewing for systems engineering skills, you don't actually have to start with a very complex system. You just start with a very simple problem, you scale it up, and you get the complexity by just scale. So you can avoid unnecessary complexity in the problem. And the last part in the definition, we had design, we had manageability, we had complexity, And the last part was life cycle. So the system as designed should be able to accommodate changing requirements. It should be able to scale up, scale down. It should be able to weather life cycle events like migration to a new geographic location, changing software versions, replacement by a successor system, and so on. So the system as designed should be able to weather these life cycle events. Now, before we go into how you would design an interview question for this type of interview, I'm going to give you one example. I'm not going to go too deeply into the example, but this is just to give you an idea of what types of questions we ask in these interviews. And the example is the following. The interview question is, design a system that copies a file to some machines. There's one sentence. Copy a file to some machines. And you might be thinking, well, that's simple, right? I mean, why would you even ask that sort of question? You just do a for loop, you do a secure copy or an rsync with your machine list, and you just copy the file to the machines. What's the difficulty in that? Well, once you've posed the interview question like that, copy a file to some machines, then you add scale. Let's say the file that we want to copy is 100 gigabytes in size. Let's say we want to do this once a day, and we want to copy from the source machine to, say, 100,000 target machines, which, by the way, are on the moon. We are perfectly allowed to make up ludicrous requirements for these questions. So as you add these requirements, 100 gigabytes in size, once a day, to 100,000 machines, the solution becomes more complicated, because suddenly you realize, well, if our source machine only has, say, 100 megabits per second network card, then it's going to take us 10,000 seconds to transfer data from the source machine. That's about 3 hours. So that means that we actually cannot transfer sequentially from the source machine in one day. So we need to figure out, well, how are we going to do the transfer? How are we going to use intermediate machines? Do we even have enough total network bandwidth available to do this transfer? If individual machines are down, if some of these 100,000 machines are down during the transfer, how are we going to handle that? How are we going to do accounting for which machine has received the data and which hasn't? And then we get the machines on the moon. How does that affect us? Does the extra network latency affect us, and so on? And we get to the question, well, this is suddenly becoming more and more complex. Which components do we need to design to solve this problem? And I'm not going to go into how to solve this particular problem right now, but this is just to give you an idea of how you can take a simple problem and then scale it up to make the solution more complex. You take a simple problem, copy a file to machines, and then you scale it up, add extra requirements, and then suddenly the solution becomes more and more complex. So, how would you design such an interview question? Well, first thing we already talked about, pick a problem that's not too complex. Pick a problem that you can state very succinctly, very briefly. A problem like copy a file to some machines, collect some data from some machines, serve some web requests, serve some database requests, and then just make it ludicrously complex. because the complexity will come with the scale. And as you're designing these questions, pick a problem area that you're familiar with. Pick something that you've worked on before. That might be something like large-scale web serving, data processing, message passing, something that you're familiar with, where you know how the standard solutions work to this problem. We might be getting something. Let me catch up on the slides. Otherwise, I'll just keep talking. And then once you've picked your problem, you scale the problem up. Typically, what we want to achieve is a problem that needs on the order of 100 to 1,000 machines to solve. That's the sort of scale that we're looking for. And you can feel free to make up ludicrous requirements in order to get to that scale. Like, if your simple problem, if you wanted to require 1,000 machines to solve, and in order for that to happen, every man, woman, and child on the planet would have to use it 20 times a day, well, that's your requirement. That's your business objective. You want to reach the entirety of humanity. And that's perfectly fine for this type of interview. Now, the next thing you do is, once you've identified the problem and you've scaled it up sufficiently, you identify the bottlenecks in your system. So what is the bottleneck dimension for your chosen architecture that is going to determine the shape of the system? And bottlenecks come in a variety of shapes. You could have a system that's bottlenecked on network bandwidth, that's bottlenecked on disk I/O bandwidth. It could be bottlenecked on disk operations, and so on. It could be bottlenecked on memory bandwidth. Whatever bottleneck dimension crops up in the solution for your problem. And good interview questions of this type have multiple potential bottleneck dimensions. So if the candidate can immediately identify, oh yeah, the bottleneck for this problem is going to be network bandwidth, well, that makes the interview less interesting. So you want to pick a question where it's not immediately clear from the beginning what is the bottleneck dimension. Now, when we're talking about these bottlenecks, we run into a little bit of a problem, which is that modern hardware is pretty much magical. So, like 10, 15 years ago, it was pretty easy to have problems that require a cluster of machines to solve, that require a couple of hundred or a couple of thousand machines to solve. Because 10, 15 years ago, the standard server had maybe 2 CPUs, it had maybe 8 to 16 gigabytes of RAM, and that is what was what was attainable for most organizations, for most companies. You could buy a 1U server with like 2 CPUs, 16 gigs of RAM for maybe $2,000 US. On the other end of the spectrum, 10 to 15 years ago, we had these supercomputers. We had these large mainframe-type machines that had like 70-something CPUs, a terabyte of RAM, but they were also very expensive. They cost like $6 million US in 2004 to 2006. And for most organizations, like they could never attain such a piece of hardware because it was just too expensive. Now, I looked at the pricing guide for Google Compute Platform, and Google Compute Platform right now offers you, as the largest instance, an instance with 96 CPUs and 1.5 terabytes of RAM. This is pretty similar to the specs of like a high-end supercomputer of 10, 15 years ago. And you can buy this for $5,500 US a month. Lots of organizations can Lots of organizations can afford that. Like $5,500 a month is not a large running cost for even a small company. So these supercomputer type machines of 10 to 15 years ago, they're very attainable for most organizations these days. And that makes a lot of problems single machine sized. A lot of problems become much easier if you can run them on a single one of these very large resource machines. So this is the one problem when we're trying to make up problems that require hundreds or thousands of machines to solve. The other problem is SSDs. SSDs have pretty much made seek times and I/O operations per second and I/O transfer bandwidth for hard drives a non-problem. A typical hard drive needs like 10 milliseconds for a seek. So an SSD takes 0.1 millisecond for a seek. A typical hard drive can do about 100 I/O operations per second. An SSD can do up to 100,000. And SSDs can transfer up to like 2.5 gigabytes per second, where a hard drive is usually limited to about 200 megabytes per second. So for a lot of problems, the hard drive bottleneck goes away once you put them on SSDs. And with modern hardware, lots of problems become single machine size. So how do we deal with that in an interviewing situation? How do we deal with that in a situation where we want to design a problem that needs hundreds or thousands of machines to solve? Well, one solution is to just make the problem bigger. Rather than targeting every man, woman, and child on Earth, we're going to target extraterrestrials as well. We can totally do that. The other problem is that we can just limit the candidate's choice of hardware. We can just tell the candidate, well, the hardware that you have available is like 2 core machines with 8 gigs of RAM and no SSD. And that will allow you to scale that problem up to hundreds or thousands of machines again. So now we have identified a problem that we want the candidate to solve. And we've identified the bottlenecks, and we've identified the requirements that will make sure that we need hundreds or thousands of machines to solve this problem. Next, we need to prepare for the interview. Now, the most useful thing I've found for preparing for this kind of interview is writing myself a cheat sheet. I have a piece of paper for each and every one of these types of questions that I ask, and I write down the problem, and I write down the requirements, I write down the numbers, I write down, yes? I write down the requirements, I write down what scale I want to achieve, how many requests per second I want the system to handle, at what latency, I write down what the data size is going to be, and so on. I write down all of the numbers that specify the size of the problem. And I also write down intermediate results. So if I give the candidate, say, number of requests per second that the system should handle and the average request size, then I'm going to multiply those and figure out and write down the total network bandwidth required for that. Because at some point in the interview, the candidate is going to do that calculation on a whiteboard somewhere to try and figure out what is the total network bandwidth required to solve this problem. And while the candidate is doing that calculation on the whiteboard, I'm doing 3 things at the same time as the interviewer, which is I'm taking notes, I'm trying to check the math on the whiteboard to see whether it's correct, and I'm trying to think ahead what the next question is that I'm going to ask. So by writing down the intermediate results, I just take out that one step of needing to check the math, and I make life a little bit more easy for myself. So we've got that. So that allows me to cross-check the solutions without actually having to do the math over again in my head. And the last thing that I write down is follow-up questions. So once we've arrived at one design, then I'm going to ask follow-up questions about things like failure modes, about things. I'm going to change requirements on the candidate. I'm going to ask them to handle life cycle events. I'm going to ask them to migrate the system to some other system, and so on. So all the potential follow-up questions that I might want to ask, I also put on my cheat sheet. So this makes sure that I don't run out of questions to ask during the interview. And that usually fits on like a small piece of paper that I have in my notes. I usually try not to let the candidates see this during the interview because that would give away some of the solutions. Although I have also found out that some candidates are incredibly good at reading even my bad handwriting upside down across the table from them. So I have been surprised in that regard. So you write the cheat sheet and you take in preparation for the interview. And the next thing you do is you practice. Never go into an interview with an external candidate with a question that you've never asked before. Always ask the question with somebody else before you use it in a real interview. So that somebody else could be a coworker of yours, that could be a friend of yours, and just do a practice interview with them to figure out how this question is going to work in a real-life interview situation. Because you might be surprised. You might think that you came up with the perfect interview question, and you try it out for the first time with one of your friends, and you might realize that it could be far too simple. Your friend could blaze through that question in 5 minutes and be done with it. And then you sit in the interview with like almost an hour to go, and you don't know what else to ask. Or it could be far too complicated. You might need a lot more than a single interview to actually get through the meat of that question. You can find out things about how you're setting up the question, that maybe how you're explaining the problem is misunderstandable, it's misleading, and you're wasting time in explaining the problem over and over again, and so on. So practice is really important in order to get to a successful interview question. Practice interviews will also allow you to calibrate your expectations. So if you're doing this sort of interview with a coworker that you respect a lot for their systems engineering skills, then you might figure out in the practice interview what is the type of answer that is given by a very good systems engineer, and that allows you to calibrate what you expect. And always keep in mind that when you're doing an interview, you have a limited amount of time at your disposal. So at Google, most interviews run 45 minutes. At your company, maybe you use an hour, but you're not going to keep an interview candidate in a room for much longer than an hour. So you need to get to a solution in that limited amount of time. Now comes a part of the talk where having slides would be really, really useful. But we're going to get through this anyway. Because the next part of the talk is about what you do during the interview. And before we talk about how you behave during the interview, we need to talk about what our job as an interviewer is. What do we actually do in an interview as the interviewer? And I found it very useful to frame interviewing as a learning problem. So you might have heard the term hiring bar in the past. So we very often envision interviewing and the interview candidates that we get as having different skill levels, and we kind of rank the candidates based on their skill level. And at some point, we draw a line and say, okay, everybody who is above this line, which we call the hiring bar, they are skilled enough to be hired, and everybody below this line is somebody that we don't want to hire because we don't believe they are skilled enough for this job. So we sort of partition the space of candidate skills into two parts, into hireable and non-hireable. And that sounds very much like a learning problem. That sounds very much that sounds very much like a statistical learning problem, where we try to separate an instance set into two categories. Now, that is a very so that is a very natural way of thinking about interviewing. The job of the interviewer is to determine whether a candidate falls above the hiring bar or below the hiring bar. But when you look at this problem a little bit more closely, you realize that the problem is not whether the candidate is above or below the hiring bar. The problem is uncertainty. So we envision this very simple space of candidates and skill levels and candidates falling either below or above the hiring bar. But in reality, we don't really know what the candidate's skill levels are. So as we start out the interviewing process, we have very little information about the candidate. Pretty much, most of the time, it's only a resume with previous employers and previous activities. And we don't really know what the skill levels are. So rather than like having the candidate being at one specific point above or below the hiring bar, candidates come with huge error bars. And for most candidates, we don't really know where they are in relation to the hiring bar. They could be above the hiring bar, they could be below the hiring bar, but the uncertainty is so big that we don't know exactly where they fall. I mean, there might be candidates where even given the uncertainty, we're pretty sure that they're then below the hiring bar, so we could discard these immediately. But for a lot of candidates, they're going to touch the hiring bar somewhere in that uncertainty. And we need to figure out where exactly they are compared to the hiring bar. So that gives us a more useful definition of what our job is as an interviewer, which is the job of an interviewer is to decrease the error bars. The job of an interviewer is to decrease the uncertainty of where a candidate is in comparison to the hiring bar. And as you do more interviews with a candidate, as you do follow-up interviews, for example, you're going to decrease the error bar even more. And at some point, you feel confident enough to make a decision whether the candidate actually is below or above the hiring bar. So this is your job as an interviewer. Your job as an interviewer is to decrease the uncertainty of what a candidate's skill level is. And this also means that how good of a job you do as an interviewer depends on how successful you are at decreasing the uncertainty. If you do an interview and you go out of the interview and you're like, well, I'm actually no closer to deciding whether we should hire this person or not after the interview than I was before, then you've basically wasted your time and the candidate's time. So the more you can decrease the error bars, the more you can decrease the uncertainty, the better job you've done as the interviewer. And this also means that your job during the interview is to extract signal from the candidate's answers, from the candidate's behavior that allow you to decrease this uncertainty. And time that you're not using to decrease the uncertainty is basically time wasted. Got about 10 minutes? Okay, very good. So this is your job during the interview. Decrease the uncertainty and the uncertainty on the candidate skill levels. So that is going to inform your behavior as the interviewer during the interview. So first thing that you can do in order to extract the maximum amount of signal from the interview is set clear expectations. Tell the candidate upfront what you expect from them, because that will reduce misunderstanding and that will give you more time to actually probe into this candidate skills. So tell the candidate from the beginning that what you're doing is not a coding interview. In the systems design interview, you don't expect the candidate to write code. Tell them from the beginning that you expect them to ask questions. You're going to present a very underspecified problem to them, problem like copy a file to some machines, and you expect the candidate to determine what the actual requirements are for the system that they're going to build. You expect candidates to pick a solution. So many of the problems that we're going to present have more than one possible solution. But in order to come up with a coherent design, we will need to pick one solution and then explore that. So we expect the candidate not to stay in this space of uncertainties, but actually make decisions on what they want to build. And we're going to expect candidates to explain their rationales, not just come up with a solution, but also be able to articulate why they picked that particular solution. So this is setting expectations. The other thing that you might find yourself needing to do during an interview is you might need to steer candidates in particular directions. Because remember, the goal of the interview is gathering as much information about the candidate's skills as possible. So time that you spend with the candidate being stuck and misunderstanding your problem, or time that you spend going into the wrong direction, like a candidate, you presenting a question to a candidate, and then the candidate writing code on the whiteboard for 10 minutes, even though you didn't want them to write code, that is wasted time in the interview. So you might need to steer candidates in particular directions during the interview. And I want to stress that a candidate misunderstanding you or a candidate going off into the wrong direction is not a sign of a candidate not being skilled. Because for many candidates, this is probably the first time they've done this type of interview. They might not understand what the goal of this type of interview is. And this has nothing to do with their skills in system design. They might just not understand what type of skill you're specifically looking for. So careful steering allows you to gather more time and gather more information and use the interview time more effectively. Over many years of asking these types of interview questions, I've noticed that I used the same hints over and over again in this type of interview, in specific interview situations that happen to crop up fairly regularly. So I'm going to share some of those hints with you so you can use them in your own interviews. One phenomenon that I've observed lots of times is that many candidates don't provide concrete resource estimates. You ask them to design a system, and they don't provide concrete estimates for how many machines it's going to need, how many hard drives, and so on. So what I usually tell them at some point is, well, let's say your vice president has looked over your design, and the vice president says it looks good. Now, what needs to go on the purchase order for the hardware so we can build your system? So this makes it very clear that, yes, we're looking for actual actual hardware, actual machines that we can use to build the system. Another problem that I run into very often is that there's no clear boundaries between different systems that work together to solve the problem. So what I usually tell candidates in that situation is, well, imagine you have 3 teams of engineers that are going to implement your system. What task do you give each of those teams of engineers? Or it could be 4 teams or 5 teams or whatever. So that gets the candidates to subdivide the problem into separate entities that teams can work on independently. Sometimes candidates get stuck on resource estimation. They might be spending lots of time doing like overly precise arithmetic on the whiteboard. So I usually give them examples of allowable rounding. So one thing that I very often tell candidates, yeah, one day has about 100,000 seconds. That's within 15%. That's more than close enough for our purposes. Because the goal of the resource estimation in this type of design interview is we basically want to determine orders of magnitude. We want to know whether we can solve this problem with 1 machine, 10 machines, 1,000 machines, or more machines than there are in the entire company. So that's the type of resource estimation that we want to arrive at. And the last thing that I very often run into is the magic bullets. That candidates want to use some piece of standard technology. They say, oh yeah, I'm just going to use Redis for this. I'm just going to store this data on the Google file system. I'm going to use BitTorrent to distribute this data. Because they might be thinking that we're testing for knowledge. They might be thinking that we want to know about how well they know these pieces of technology, when in reality, we want them to design something from scratch. So in that case, I might ask, well, how does this technology actually work? And for a lot of open source technology, that's actually a very honest question from my side, because I don't know. I only barely know how Redis works or how Docker works because, well, Google has so much homegrown technology. So I'm going to ask, how does this technology actually work? Why is this a particularly good fit for our problem? Or how would you re-implement this type of technology? Now, I think I have about 3 minutes left at this point. So the last thing that we need to talk about is how do we determine how well the candidate did in the interview? And the most important thing for determining how well a candidate did in the interview is deciding before the interview what you actually want to see in the answers. Don't go into the interview with no idea of what you expect from the candidate. Decide before the interview what you want to see in the answer and what constitutes an acceptable answer, a good answer, or an excellent answer. These types of assessment guides, they're usually called rubrics, and they're very popular in interviewing because they help you be more objective and reduce bias in the assessment of the candidates. And so you should have a rubric for this type of interview as well, for systems design interviews as well. So for each of the categories that we have, and for each of the axes that we have in the interview, you might make up a couple of expectations. So when we're talking about system design, you might want to score the candidate based on, did they come up with a high-level design at all, or did they get stuck in some little piece of the design? Does the system as designed solve the problem, or did they build a system that actually solves a completely different problem? That sometimes happens at all. Does the system follow good design principles? Are there single points of failure in the system, and so on? So that would be your score for your scoring help for system design. Resource estimation, you might ask, did the candidate arrive at a high-level resource estimate? Did they identify resource bottlenecks? Very good candidates, you might also see them trading off different resource dimensions against each other. For example, use more CPU time to reduce network bandwidth. You're probably going to ask about failure modes. So you're going to assess candidates based on, did they identify the possible failure modes of the system? Did they mitigate the failure modes? Did they identify a suitable SLO for the system? And for very good candidates, did they prioritize which failure modes they mitigate based on the impact on the SLO? You're probably going to be asking about lifecycle management, so you might assess the candidate based on whether they came up with strategies for releasing new version of the software, doing data pushes, migrating systems, and so on. All right, and that brings me to the summary. So we talked about interviewing for systems design skills, and the reason why we interview for systems design is that systems design is a core part of systems engineering, and systems engineering is a core part of site reliability engineering. So systems design is a core SRE skill. So how do we interview for systems design? We pick a simple problem and then add complexity by scaling it up. If you do this type of interview format, you need to prepare and you need to practice the interview. You might need to steer candidates in the right direction to make best use of the interview time. And after the interview, you should rate candidates based on a predetermined rubric and assess the performance in the core systems engineering principles, like systems design, failure mode analysis, resource estimation, and so on. And I think that brings me to the end. Is that right, Matt? Okay, very good. Thank you very much.